Welcome to Regression Tutorial 2. In this tutorial we will see how to create a model. In particular, we will look at how to successively eliminate variables from the model to arrive at a parsimonious model. As in the previous tutorial, we again will look at our example of predicting wine prices of bottles of wine. Our independent variable are the points from a Robert Parker survey, the age of the vineyard, recent vineyard awards, recent write-ups, if the wine is from Burgundy, if it's from other areas of France, if it's from Australia, from Oregon, or from California. And we also have wine from other areas, but that we do not particularly indicate, because if it's not from any of the 5 indicated regions, then obviously it must be from one of the other regions. Before I start, however, I will put some data aside. In particular, I just limit our data set. Instead of using all 114 data, I limit our data set to 100 data points. The remaining 14 data sets I will later, in the final tutorial in this series, use for testing the model. For now, let's get back to the data. And now let's do the first step, what I do at the very beginning before I run a regression. Rather than running the regression, I first run a correlation matrix on all my data. So I go to Data, Data Analysis, and now I look up here for correlation, enter OK, and my input range is from B1 to K101. I have labels in the first row. Yes, my data is grouped by columns. The new worksheet ply I call correlation matrix and hit OK. And this, after cleaning up, will look something like this. Well, so far I don't see much of a story here for our regions. At best, Australia has some negative correlations with price. For our independent variables, points seems to be strongly correlated with price, recent vineyard awards and recent write-ups to some degree, and age of vineyard as well. So let's see if this is going to be a good regression. Perhaps there are some surprises here that we don't see from the correlation matrix. Within the correlation matrix, there is basically no correlation between the variables, except that recent write-ups seems to be correlated with recent vineyard awards. Now that makes sense. Perhaps vineyard awards may actually lead to press coverage. So here is an interesting story developing. Let's see how this will work out when we decide how to build the model. The next step now will be to actually run a regression over the entire data. So let's go back to our sheet with the data. So now, to run a full regression over our data, we go to our Data tab, as always, go to Data Analysis, look for regression, hit OK. Our input Y range is the range from B1 to B101. Our input X range is the range from C1 to K101. Let's make sure we select labels. Let's call the new worksheet ply total regression. Hit enter, and the result look something like this. And after cleaning up, like this. Well, first of all, the R square, 73%, that's not bad. The points, age of vignette, recent vignette awards, recent write-ups, all have coefficients with the right sign. At least that's the sign we expect. Burgundy seems to have a premium, other France not. Australia a very small premium, Oregon quite a premium, and California a penalty. Australia's p-value is really poor, but most p-values are poor. All the regions have poor p-values. Recent write-ups has a fairly poor p-value as well. Not too surprising since it was correlated with recent vignette awards. So now we have to make a decision what we are able to take out. Naturally, Australia would be the prime candidate to take out. However, since Australia was fairly highly correlated with price, at this point I would rather like to take Oregon out. Now here's where working with Excel becomes a little bit cumbersome. Since the independent variables need to be put in adjacent cells, we physically need to move Oregon out and need to move California over. Now we can go back to data, data analysis, regression, input Y range is still there. The input X range now is only going to go until J, not K. And let's call this total regression Oregon. That means Oregon is out. And hit OK. After cleaning up, this looks like this. And our new regression hardly left any predictive value. In particular, our R square hardly went down. The coefficients still look right in sign, but not much has changed with our p-values. So now I think it is indeed time to take Australia out. With Australia removed, the regression output looks like this. Again, no visible decrease in R square. Again, our region p-values are fairly bad. Burgundy now starts to get some kind of credibility, but still far from being good. At this point, I would take California out. Once again, there's almost no fall in R square. Our p-values for the regions and for recent write-ups are still not very good. At this point, I would take recent write-ups out. Once again, R square is minimally reduced by removing recent write-ups from the regression equation. Other France now is the next candidate to removed, and with other France removed, the regression will look like this. Again, no perceptible drop in R square. Our first three independent variables are still highly relevant. Burgundy, at least now at the 90% confidence level, becomes relevant. However, given how little the correlation was between Burgundy and price, I would be doubtful if it was actually a meaningful variable. Alternatively, one may look if one of the other regions all by itself has a better p-value and becomes influential. Australia, since it had the highest correlation with price, might be a good candidate. So there are several ways to go from here. For now, I will leave it at this and keep this as the final model. In the next tutorial, I will show how to validate this model and then finally how to test this model on out-of-sample data. In the next tutorial, I will show how to validate this regression and then finally how to test it on our test data.